Hello and welcome to my channel IGCSE with Sadaf. Our topic of discussion today is iron extraction. Today we will go through a quick revision of the topic extraction of iron first. Then we will solve some questions from paper 2 from the same topic. Let's go through the quick revision of the topic. In this picture, a blast furnace is shown where iron ore is reduced to iron to purify the iron. This is the method of extraction of iron from iron ore. Three charges or the raw materials are added to the furnace: coke, which is carbon; iron ore, that is iron oxide or hematite or Fe2O3; limestone, which is CaCO3 or calcium carbonate. These three substances are added from the top into the furnace. Here, hot air blast is entered into the furnace. Molten iron leaves at the bottom and waste gases escape from the top of the furnace. Important reactions which we have to learn. The first reaction that happens here is combustion of carbon. Carbon plus oxygen make carbon dioxide. This reaction is very important because it increases the temperature of the furnace. So temperature almost reached 1900 degrees Celsius. This is highly exothermic reaction. They can ask you what is the importance of this reaction. This reaction is exothermic, so it increases the temperature of the furnace. Then this carbon dioxide reacts with further carbon and it is changed into carbon monoxide. So here you can see reduction happens. Carbon dioxide is reduced to carbon monoxide, and here temperature drops. After that, this carbon monoxide is used to reduce iron oxide ore. Iron oxide reacts with carbon monoxide. In this equation, you must learn the balancing of the equation. So it makes iron, because our purpose is to separate the iron, plus carbon dioxide, which is the waste gas from the furnace. To balance, because Fe2, as the ionic compound formula tells that iron valency is 3, so by crossing over we get Fe2O3. So 2 Fe are there, so by balancing, Fe is 2, O is 3, and here you can see O is 3, so 3 to the 6, 3 carbons. That equation needs the practice to balance, or you can learn the balanced equation as well if you have short time. These three are the important reactions: first step, second step, and third step. There is one more additional step which is very important. Remember that molten iron flows down the furnace and hot gases rise up the furnace, like carbon dioxide gas. The third thing is also added, which is calcium carbonate. They can ask you why we add this one. It is decomposed thermally, yani by heat, into calcium oxide plus carbon dioxide. This calcium oxide, because it is a basic oxide, it is used to neutralize the acidic impurity, that is silica or silicon dioxide. By neutralization reaction, they react together and make slag. The slag is named as calcium silicate, CaSiO3. So this step is just to remove the impurity. That's why we add calcium carbonate into the furnace. The next step is the basic oxygen process. Carbon is changed into carbon dioxide by reacting with oxygen. Any sulfur impurity changed to sulfur dioxide, which is also waste gas, and they escape from the top of the furnace. Then we add this all iron obtained from the furnace into the tilting furnace in the basic oxygen process, and oxygen gas is blown into the tilting furnace. Again, calcium oxide is added to remove any kind of impurity. The gaseous because CO2 and SO2 can escape as gases, but silicon and phosphorus, they are solid. They do not make gaseous oxides, so calcium oxide is added to remove them by neutralization process. They will make slag and they will float on the top of the molten iron again. Here we collect the molten iron from the furnace by tilting, and then they add different elements to make alloys like chromium, manganese, tungsten, any other transition metal to make different types of steel. As you know, mild steel is having little amount of carbon, but stainless steel is having different elements. It's a clear picture of blast furnace, very simplified. These three raw materials are added to the blast furnace. From this passage, the waste gases are escaping. From here, the hot air is blown. Slag is always over the molten iron because of the density difference. Molten iron is more dense than slag, and they are collected from the bottom of the furnace. This revision will be really helpful. This revision will be very helpful for solving any kind of question. Now you can easily summarize all the steps and solve the questions. Question 1 is saying iron from blast furnace is treated with oxygen and with calcium oxide to make steel. Which substance in the iron are removed? They are asking the next step. Yani after the iron extraction is done, the next step when we do in the tilting furnace. So why we add oxygen? Because oxygen removes carbon, of course not iron, carbon. And calcium oxide removes, calcium oxide is a basic oxide, it will remove any acidic impurity, so acidic oxide. So the answer seems to be carbon and acidic oxides. Carbon and acidic oxides, because calcium oxide is a metal oxide or a basic oxide, so it will be neutralizing only acidic oxide. So right answer is option A. Question number 2 says iron is extracted from its ore hematite in the blast furnace. Which gas is produced as a waste product? We have just revised there are two gases, carbon dioxide and sulfur dioxide. So options are carbon dioxide, yes, it is. Then comes hydrogen, nitrogen, oxygen. No, none of these gases are waste products. So right option is carbon dioxide. Next question says molten iron from blast furnace contains impurities. So again, this is the step after extraction done. The process of turning the impure iron into steel involves blowing oxygen into the molten iron and adding calcium oxide. What are the reasons for blowing in oxygen? Blowing in oxygen we do to remove any impurity like carbon, like sulfur, and adding calcium oxide. We add calcium oxide to remove impurities like silicon or any acidic impurity to make the slag. So blown in oxygen, let's see all the options one by one. Carbon is removed by reacting with oxygen. Yes, this is true. Carbon is removed by reacting with oxygen. Yes, it could be the option also. Iron reacts with oxygen. Iron does not react with oxygen. Then comes here calcium oxide. It reacts with acidic impurity making slag. Yes, it seems to be correct. React with slag and so removes it. No, it reacts with acidic impurity making a slag. Yes, but this part is not correct. it reacts with slag and so remove it? No. So option A is the right option. Clear? Next question says that iron is extracted from hematite in the blast furnace. Hematite contains silica. Silica is SiO2 as an impurity. What reacts with the impurity to remove it? We need something basic or metal oxide to remove this silica by neutralization process, as we just discussed. Options are calcium oxide, yes. Carbon, no. Carbon dioxide is no because it is acidic. Oxygen is neither acidic or basic. So we need calcium oxide because it's a basic oxide or metal oxide. So option A is the right answer. Iron is extracted from its ore in a blast furnace. Hematite, coke, limestone, and hot air are added to the furnace. Which explanation is not correct? Coke burns and produce high temperature. Yes, the first reaction. Hematite is the ore containing the iron as iron oxide. Yes, this is correct as well. Hot air provides the oxygen for the burning. Exactly, hot air provides the oxygen. Limestone reduces the iron oxide to iron. No, limestone is not added for reduction. It decomposes into lime, calcium oxide plus carbon dioxide, and the calcium oxide, it reduces the acidic impurities like silicon dioxide or silica. So correct option is D. Next question is, many metals are extracted from their ores by heating the metal oxide with carbon. Which metal cannot be extracted by using this method? Options are aluminium, copper, iron, zinc. Any metal which is above carbon in reactivity series, it cannot be extracted by using carbon. Only the elements or metals which are less reactive than carbon, they can be extracted by using carbon. So look at the reactivity series. These are the metals arranged in the reactivity series. Here you can see carbon, the aluminium is above carbon, and the other ones are copper, iron, zinc. All are below carbon, so they can be extracted by this way. Aluminium cannot because aluminium is more reactive than carbon. So option A is the correct answer. Thank you so much for watching, everyone. Good luck for your exams. And don't forget to subscribe my channel IGCSE with Sadaf and share with other students. Goodbye, everyone.